Microsoft Excel, a spreadsheet editor developed by Microsoft for Windows, Mac OS, Android, iOS, and iPad OS. It features calculation or computation capabilities, graphing tools, pivot tables, and a macro programming language called Visual Basic for Applications, VBA. Microsoft Excel is a software that you can use to organize data for your work and everyday life. Learn about formulas, functions, and more that you can apply when using Excel. Microsoft Excel can be an incredibly powerful tool to learn for your career, with benefits for everyone from data analysts to social media marketers. It allows the everyday user to create charts, graphs, and more to organize and visualize data. Microsoft Excel is far more than a tool for numbers. It is a versatile platform for creating a wide variety of documents that serve both professional and personal purposes. One of the most common types of documents created in Excel is financial and accounting records, including budgets, expense trackers, balance sheets, and income statements. Businesses often use Excel to prepare financial forecasts, investment analysis, and cash flow reports, as its formulas and functions allow for dynamic calculations and scenario planning. Excel is also widely used for data reports and dashboards, where charts, graphs, and pivot tables visually summarize complex data sets. For instance, sales teams can create reports showing monthly performance, regional comparisons, and product trends, while managers can build dashboards that track key performance indicators, KPIs, in real time. Beyond finance, Excel documents include schedules, calendars, and project plans, which help teams organize tasks, assign responsibilities, and monitor deadlines efficiently. In addition to professional documents, Excel is frequently used for personal organization and planning. Individuals can create personal budget spreadsheets, household expense trackers, and savings planners, allowing them to monitor income and spending patterns effectively. Students and researchers often use Excel to organize data for assignments, lab results, and research projects, taking advantage of its calculation and visualization features to interpret results accurately. Excel also supports inventory lists, checklists, and event planning documents, making it useful for small businesses, clubs, or personal projects. Even creative applications, such as habit trackers, meal planners, or fitness logs, can be designed in Excel using its grid layout and conditional formatting. The flexibility of Excel allows users to customize the structure, formulas, and visuals of each document, making it a practical and dynamic tool for a vast array of tasks beyond traditional number crunching. Microsoft Excel is one of the most influential software applications in the modern digital era, occupying a central role in how individuals, businesses, educators, scientists, and governments organize, analyze, and communicate data. At its core, Excel is a spreadsheet program that allows users to arrange information into rows and columns, perform calculations, and interpret results through charts, formulas, and other analytical tools. Yet understanding Excel demands much more than a description of its basic features. It requires exploring how the application has evolved over time, why it became the industry standard, how it supports decision-making across sectors, and what strengths and limitations define its role in the rapidly changing technological landscape. Since its introduction in the mid-1980s, Excel has grown from a simple desktop calculation tool into a versatile analytical platform used worldwide, shaping how data is managed and interpreted in the digital age. The origins of Microsoft Excel can be traced back to the earliest days of personal computing, when businesses and individuals were transitioning away from manual bookkeeping and ledger systems to computerized data handling. Before Excel, electronic spreadsheet concepts were pioneered by applications such as VisiCalc and Lotus 123, which offered early adopters the promise of automated calculation and organized data storage. These programs revolutionized accounting and financial work by enabling users to replace paper calculators and ledger books with dynamic digital worksheets. Microsoft entered this competitive space with the first version of Excel for the Apple Macintosh in 1985, followed by a version for Microsoft Windows in 1987. Excel distinguished itself from competitors through its user-friendly graphical interface, flexibility, and extensive formula capabilities. While competitors like Lotus struggled with adapting to graphical operating systems, Excel capitalized on Windows' growing popularity, allowing users to interact with data visually, a feature that proved critical to its widespread adoption and success. As personal computing grew in corporate and academic settings, so too did Excel's functionality. Early versions focused on basic calculation and data organization, yet subsequent releases introduced more powerful features such as advanced formulas, charting tools, pivot tables, and later mechanisms for automation and scripting. Excel's integration with other applications within the Microsoft Office suite further strengthened its position as the spreadsheet standard. Users could easily export data to Word documents, embed tables into PowerPoint presentations, or import information from external databases, increasing productivity across multiple tasks. Over time, Microsoft continuously updated Excel, responding to user needs for greater data capacity, improved analytical features, and better visualization capabilities. The result is a software platform that is accessible to beginners yet powerful enough to support complex computations, making it indispensable for various professional and personal purposes. Understanding Excel's core structure helps clarify why it is so effective. Excel presents information within a grid of cells arranged into rows and columns, where each cell can contain numbers, text, dates, or formulas. The grid format allows users to segment and categorize data logically, while formulas enable calculations ranging from simple arithmetic to advanced statistical and financial modeling. Functions predefined formulas such as sum, average, if, VLOOKUP, and their modern counterparts like SLOOKUP assist users in manipulating data without needing deep programming expertise. By entering or selecting functions, users can perform calculations across data sets, compare records, and extract meaningful insights based on predefined criteria. Sorting and filtering tools further enhance Excel's ability to manage and analyze information, making it possible to locate, reorganize, and interpret data efficiently. Beyond basic calculations, Excel offers powerful ways to present information visually. Charts, graphs, pivot tables, and conditional formatting allow users to highlight trends, patterns, and anomalies within data. Visual elements such as bar graphs, line charts, and scatter plots make complex information more accessible and understandable, supporting better communication of analysis results. Conditional formatting, for example, enables users to apply color coding or visual indicators based on cell values, which helps identify outliers or emphasize important trends. Pivot tables, one of Excel's most celebrated features, allow for rapid summarization and exploration of large data sets, as users can pivot or rotate fields to view data from different perspectives. These tools transform raw information into digestible visual narratives, making Excel both an analytical engine and a communication platform. The uses of Microsoft Excel are extraordinarily diverse and cut across numerous domains. In finance and accounting, Excel is fundamental for budgeting, forecasting, financial modeling, and auditing. Accountants rely on its ability to perform complex calculations, project scenarios, and reconcile financial statements. Excel allows companies to model future revenue and expenses, perform break-even analysis, and evaluate investment decisions through functions like net present value, NPV, and internal rate of return, ER. Financial professionals often build dynamic models where changing one assumption automatically updates the entire spreadsheet, enabling rapid what-if analyses and scenario planning. These capabilities make Excel invaluable for evaluating business viability, optimizing resource allocation, and supporting strategic financial decision-making. In the field of education, Excel is widely used by teachers and learners alike. Educators use the platform to manage grad ebooks, track attendance, analyze classroom performance trends, and prepare administrative reports. Students utilize Excel to organize data for research projects, perform statistical calculations, and visualize findings clearly and persuasively. Because Excel is intuitive and visually oriented, it serves as an effective learning environment for teaching analytical reasoning, data interpretation, and numeric literacy. As schools and universities increasingly emphasize data literacy as a critical skill for future careers, Excel provides a foundational tool through which students learn to manipulate data sets, construct meaningful summaries, and draw evidence-based conclusions. Scientific research also benefits from Excel's organizational and analytical tools. While advanced statistical or simulation software may be used for high-end modeling, many researchers begin with Excel for exploratory data analysis, cleaning raw data, and constructing initial charts. Excel enables researchers to quickly spot trends and anomalies, calculate descriptive statistics, and prepare datasets for further analysis in more specialized platforms. Its ease of use and straightforward interface reduce barriers for researchers who may not be trained programmers, making it a practical starting point for many scientific investigations. Excel's impact extends beyond professional and academic spheres into everyday personal and business use. Individuals use Excel to manage household budgets, plan expenses, track savings goals, or organize schedules. Small business owners rely on Excel for inventory tracking, sales reporting, and financial planning, where investing in specialized software may be cost prohibitive. This versatility from simple task organization to complex analytical workflows underscores why Excel remains ubiquitous in both personal and professional contexts. One of Excel's most transformative strengths is automation. Through tools like macros and Visual Basic for Applications, VBA, users can automate repetitive tasks that would otherwise be time-consuming and error-prone. Macros allow users to record sequences of actions such as applying formatting, performing calculations, or generating reports and play them back with a single command. VBA, meanwhile, enables custom scripting that enhances Excel's functionality beyond its built-in tools. Users can write VBA code to create custom functions, develop interactive data entry forms, automate report workflows, and build specialized analytical tools tailored to unique organizational needs. For example, an accounts team might use VBA to automate monthly reconciliation reports, while an operations team could build tools that streamline inventory updates. Automation reduces manual effort, minimizes errors, and frees valuable time for higher-level analysis and decision-making. In addition to its desktop functionality, Excel has evolved in the era of cloud computing. Microsoft 365 and Excel Online allow files to be created, stored, accessed, and edited across devices from virtually anywhere. This cloud-based feature supports real-time collaboration, enabling multiple users to work simultaneously on the same spreadsheet with changes synchronized instantly. In a world where remote work and distributed teams are increasingly common, these capabilities strengthen communication and coordination, reduce version control issues, and streamline workflows. Real-time collaboration differs markedly from earlier practices of emailing spreadsheets back and forth, which often led to confusion over the most recent version or accidental overwriting of changes. Cloud integration elevates Excel from a standalone application to a connected collaborative platform that supports dynamic teamwork across locations and time zones. Although Excel's capabilities are extensive, it is equally important to recognize its limitations. One of the most significant limitations is scalability. While Excel performs well with moderate datasets and structured calculations, extremely large datasets can cause slow performance, crashes, or data corruption. Excel has a practical row limit, although recent versions support over 1 million rows, but performance depends heavily on system memory and processing power. In contexts involving big data or high-volume analytics, specialized database systems like SQL Server, data warehouses, or analytics platforms like Python and R are more suitable. These systems are designed to handle massive datasets with high performance and advanced indexing capabilities that exceed Excel's architecture. Another limitation lies in the potential for human error. Because Excel relies heavily on manual data entry and formula construction, even small mistakes such as typing errors, incorrect cell references, or misconfigured formulas can lead to significant analytical inaccuracies. Studies and industry investigations have documented real-world cases where simple spreadsheet errors led to incorrect financial decisions, inaccurate forecasts, or flawed scientific conclusions. This risk underscores the importance of rigorous quality control, standardized validation procedures, and proper training in spreadsheet design and review. Large organizations often establish internal guidelines or peer review processes to mitigate the risk of errors and ensure accuracy in critical spreadsheets. Security and data integrity present additional concerns. Although Excel offers password protection and encryption features, its security mechanisms are not as robust as those in enterprise-level systems designed for highly sensitive or regulated data. Spreadsheet files can be shared, copied, or modified in ways that make tracking changes difficult. Version control is a challenge, particularly when multiple users work on local copies of the same file outside a shared environment. While cloud-based solutions help centralize data and improve access control, rigorous security governance still requires specialized systems when protecting sensitive information such as personal medical records, proprietary business data, or regulated financial documents. Excel is also not inherently optimized for relational data structures. Although tools like Power Query, Power Pivot, and the data model enhance Excel's ability to manage relationships between tables, they do not replace the capabilities of relational database management systems, RDBMS, like Oracle, MySQL, or PostgreSQL. For organizations with complex datasets involving multiple interrelated tables, maintaining data integrity and relational consistency often requires dedicated database systems. Excel works effectively as a front-end or analytical interface that can import, manipulate, and visualize relational data, but it is not a substitute for the robust data handling and transaction integrity provided by RDBMS platforms. Despite these limitations, Excel continues to adapt and expand its capabilities, incorporating emerging technologies and analytical methods to meet evolving user needs. One of the most notable developments is the integration of artificial intelligence, AI, and machine learning tools directly within the Excel environment. Users can now leverage features that perform predictive analytics, automated trend detection, and natural language queries, enabling data insights without extensive programming knowledge. For example, users can ask Excel to analyze a dataset in plain language and receive summaries, charts, or trend forecasts generated automatically. Such features reduce barriers to complex data analysis, democratizing access to advanced techniques that were once the domain of specialized analytics teams. Integration with business intelligence platforms such as Microsoft Power BI further expands Excel's analytical footprint. Excel serves as both a data source and a flexible front end for advanced reporting, interactive dashboards, and cross-dataset comparisons. Power BI's cloud-based dashboards allow users to publish interactive visuals that update with real-time data, supporting enterprise-level analytics alongside Excel's familiar spreadsheet interface. Through these integrations, users can leverage Excel's strengths in data preparation and modeling while deploying sophisticated visualizations and collaboration features in Power BI. Looking forward, Excel is poised to maintain its central role in workplaces, education systems, research environments, and personal productivity. Its continued evolution reflects broader trends in technology, the growing importance of data literacy, the rise of cloud-based collaboration, and the integration of AI-driven insights into everyday tools. As data becomes more pervasive across industries, the ability to interpret, manage, and derive meaning from information will be a defining skill set. Excel provides a platform for developing these skills at multiple levels, from basic spreadsheet functions to advanced analytical modeling and automation. Its accessibility ensures that users can begin with simple tasks and progressively build expertise, while its extensibility supports highly specialized workflows tailored to unique analytical needs. In modern workplaces, Excel's role remains central. Corporations use it to monitor key performance indicators, manage budgets, analyze operational and financial risks, and supports strategic planning. Departments across marketing, human resources, finance, and operations tailor spreadsheets to fit their specific analytical needs, often integrating data from cloud databases and enterprise systems for unified reporting. The ability to customize tools through macros and VBA scripting ensures that Excel can adapt to unique workflows without requiring external software development resources. Excel enhances personal productivity as well. Individuals use it to organize events, track personal goals, manage finances, and plan projects. Its flexibility supports tasks as diverse as trip planning, household accounting, and academic research. By providing a structured environment where information can be organized, calculated, and visualized, Excel empowers users to transform raw information into actionable insights in their personal lives. In conclusion, Microsoft Excel is far more than a simple spreadsheet application. It is a powerful, versatile, and continuously evolving platform that has reshaped how individuals and organizations interact with data. From its early origins as a digital alternative to pen and paper ledgers to its modern incarnation as a cloud-enabled analytical engine integrated with AI-driven tools, Excel has demonstrated remarkable adaptability and enduring relevance. Its strengths: organizing and analyzing data, visualizing insights, automating tasks, and facilitating collaboration have made it indispensable across industries, educational settings, and personal use cases. At the same time, Excel's limitations in scalability, security, relational data management, and susceptibility to human error highlight the importance of judicious use, proper design, and integration with complementary systems when necessary. Nevertheless, Excel's impact on productivity, decision-making, and data literacy remains unparalleled. Its accessibility and power democratize data analysis, enabling users of varying backgrounds to derive meaningful insights and communicate findings effectively. By bridging the gap between raw information and actionable understanding, Excel continues to empower millions of users worldwide, serving as a foundational tool in the increasingly data-driven world. As technology evolves, so too will Excel, maintaining its role as a cornerstone of digital productivity, one that not only supports today's analytical demands but prepares users for the challenges and opportunities of the future. Thank you for watching this video.